Most people never lose gold in the river. They lose it long before the pan. It happens here, at the rock itself, because gold inside ore does not behave like nuggets in a creek. It hides, it locks itself inside stone, and unless the rock is opened correctly, the gold never leaves. Imagine standing on a hillside holding an ordinary piece of quartz, white, dirty, heavy, maybe stained red or brown. Nothing about it looks valuable. Most people would throw it aside without a second thought. Prospectors hesitate because rocks speak. Some whisper, some shout, and some quietly carry wealth inside them. The first clue is weight. Pick up 2 rocks of equal size. One feels ordinary. The other feels strangely heavy, not dramatically, just enough to make you look twice. That feeling matters, because gold is heavy. Pyrite can fool your eyes. Quartz can fool your expectations. Weight rarely lies. Then comes another clue. Quartz. Not because quartz creates gold, because quartz remembers where gold traveled. Deep underground, boiling fluids once moved through fractures in the earth. The fluids cooled, quartz crystallized, gold followed. Millions of years later, the fluid is gone, the heat is gone, the mountain itself may be gone, but the quartz remains, like a fossil of an ancient plumbing system. Now another clue appears. Color, not gold, the rock around it. Red, orange, dark staining. The fingerprints of minerals that once shared the same journey as gold. The experienced prospector stops walking. The beginner keeps moving. And somewhere between those 2 decisions, discoveries are made. Now comes the mistake almost everyone makes. They start swinging the hammer immediately. Strike, strike again. Fragments fly everywhere. Possibility disappears with them. Professionals work differently. First, they study the rock. Fractures, weak points, crystal boundaries, natural break lines, because rock already knows how it wants to break. Your job is simply to listen. The first strike lands. The sound changes immediately. The outside of the rock is gone. Fresh stone appears for the first time in millions of years. Bright quartz, dark sulfides, metallic flashes, entire worlds hidden beneath weathered surfaces. Sometimes nothing appears. Sometimes one tiny yellow speck changes everything, because gold almost never distributes itself evenly. One visible particle rarely travels alone. One speck asks a question: how many more remain hidden? Suddenly the rock becomes interesting. The hammer returns. Not harder, smarter. The pieces become smaller, then smaller again, each break revealing another chapter of a story written underground long before humans arrived. Then comes the stage where most beginners stop. The pieces look small enough. Surely that must be enough. Usually, it isn't. Because gold has one final hiding place. Inside the grains themselves, a rock fragment the size of a fingernail may still imprison gold invisible to the eye. Stopping now means leaving treasure locked forever. So the crushing continues. Not violently, patiently. The sharp sounds of breaking slowly become dull grinding. Stone becomes gravel. Gravel becomes coarse sand. The original rock begins disappearing, and something remarkable happens. The more material you remove, the more valuable the remaining material becomes. You began with a rock. Now you hold concentrate waiting to happen. And for the first time, gravity is about to become your partner, because gold has spent millions of years hiding inside stone. But against gravity, it has nowhere left to run. The rock is gone. The gold is free. At least in theory, because liberation and recovery are 2 very different things. Somewhere inside that crushed material, gold may already be waiting, hidden among black sands, mixed with minerals that followed the same geological journey. The question is no longer, is there gold here? The question has become, can you separate it before it escapes? And that is where the real extraction begins. The rock is gone. The gold is free. At least, that is what most beginners believe. In reality, this is where gold becomes dangerous. Not because it can hurt you, because it can disappear, invisible, silent, gone before you even realize it was there. Because once gold leaves the rock, it immediately enters its favorite disguise. Concentrate, black sand, heavy minerals. Particles so similar in behavior that separating them becomes a test of patience rather than strength. The beginner sees dirt. The experienced prospector sees a battlefield. Now comes the first pan, not the dramatic swirling motions movies love to show, something much slower, much quieter. Water enters the pan. The crushed ore settles beneath the surface. For the first time, gravity takes control. Not you. Gravity, because gold obeys one law above all others. Weight. Gold is heavy, remarkably heavy, nearly 3 times heavier than quartz. Nearly twice as heavy as many black sands, and unlike lighter minerals, gold resists movement. Shake the pan gently. The material begins organizing itself. Large particles rise, light particles climb upward. Gold sinks, always downward, always searching for the lowest point available. The remarkable thing is this. Gold wants to be found, as long as you stop getting in its way. Then comes the mistake beginners make. They rush. Too much water, too much movement, too much confidence, and somewhere inside that rushing slurry, the smallest flakes quietly leave forever. Experienced prospectors become suspicious of speed. They trust slow movements, small reductions, tiny victories. Because recovery is not about removing gold. It is about removing everything else. The first wash removes light sands. The second removes finer sediments. The third begins revealing darker material. Black sand, magnetite, hematite. The old companions of gold return once again, and suddenly the concentrate looks heavier, darker, more important. The bucket shrinks, the pan shrinks, the material shrinks, but the value rises. This is the strange mathematics of gold extraction. The less material you hold, the more valuable it becomes. Then it happens. Not dramatically, not all at once. A flash. Tiny, stable, different from every other mineral in the pan. It doesn't sparkle. It doesn't flicker. It glows. Soft yellow, warm, unmoving. Gold. Perhaps a flake. Perhaps several. Perhaps something larger waiting beneath the remaining concentrate. This is the moment that changes prospectors forever. Because gold stops being a possibility and becomes evidence, proof that the rock told the truth. Proof that the process worked. Proof that patience has weight. But the experienced prospector still doesn't celebrate. Not yet. Because visible gold is only part of the story. Fine gold still hides below. Microscopic particles invisible to the eye may still remain trapped among the heavies. So the process begins again. Shake, settle, wash, reduce, again and again and again, because extraction is repetition, not excitement. Every cycle removes another layer of distraction. Every cycle increases confidence, until eventually, only the heaviest survivors remain. Gold, black sand, a few stubborn minerals refusing to surrender their place in the pan. Now another tool quietly enters the story, the magnet. Not for gold, never for gold. For the crowd surrounding it. Magnetic sands slowly lift away. The pan becomes cleaner. The yellow becomes brighter. The gold becomes easier to read. And suddenly, there it is. Not hidden anymore. Not trapped anymore. Not locked inside quartz. Not imprisoned inside stone. Free. For the first time in perhaps millions of years. And maybe that is the strangest part of the entire journey. You did not create the gold. You did not make it valuable. You simply completed a process. The earth started long before humans existed. Pressure formed it. Fluids moved it. Quartz protected it. Weather exposed it. The river carried it. The rock trapped it. And you finished the final chapter. Now spread the gold across a dark surface. Watch what happens. Pyrite sparkles. Quartz reflects. Gold does neither. It glows, quietly, confidently. The same color that launched expeditions, built empires, and changed the course of civilizations. And now, after all the breaking, all the crushing, all the washing, that color sits in front of you, recovered one step at a time. But perhaps the greatest discovery isn't the gold itself, it's the transformation that happened to you. Yesterday, you saw rocks. Today, you see possibilities. Yesterday, you searched randomly. Today, you search with intention. Yesterday, you chased gold. Today, you understand the process that reveals it, and that changes everything, because somewhere out there tonight, another piece of ore is waiting, another quartz vein is weathering, another rock is hiding a story beneath its surface, waiting for someone patient enough to ask the right question. Not, is there gold here? But, am I willing to finish the journey? Because gold has never rewarded speed. It has never rewarded luck. It rewards observation, patience, completion, and those who trust the process long enough eventually discover something remarkable. The gold was never hiding from them. It was waiting for them to understand how to set it free. The gold has finally reached your hand. Not the river, not the pan, not the concentrate. Your hand. After millions of years beneath mountains, months of research, hours of digging, buckets of gravel, and countless movements of the pan, the journey has finally become personal. Now another question quietly arrives. How much is it worth? Most beginners answer immediately. The weight, the scale, the number. But experienced prospectors know something surprising. Gold has two prices. The first is the metal price. The second is the story. And those two numbers are often very different. Imagine placing a small natural nugget beside a perfectly smooth gold bar of identical weight. Same gold, same mass, same metal. Yet the nugget may sell for far more. Why? Because markets do not only buy gold. Sometimes they buy rarity, shape, beauty, history. Collectors pay for uniqueness, investors pay for purity, refiners pay for metal content. 3 buyers, 3 prices, 3 completely different worlds. This is the first lesson of marketing gold. Know who is buying, because the buyer determines the value. Now comes another surprise. The gold price shown on television is rarely the price a prospector receives. The number flashing across financial markets refers to highly refined investment gold traded internationally. Natural placer gold behaves differently. Collectors may pay more, dealers may pay less. Specimen pieces may command large premiums. Quartz specimens carrying visible gold can sometimes sell for several times their metal value, simply because another specimen exactly like it may never exist again. This is why experienced prospectors rarely rush to sell immediately. First they study, then they decide. Now let us talk about 2026. Because this year has reminded the world why gold has survived every financial system humans have ever built. During 2026, international gold prices climbed to some of the highest levels ever recorded before experiencing large swings as investors reacted to inflation, interest rates, and global uncertainty. Even after recent corrections, gold remains dramatically higher than it was only a year ago. Trading economics +1. At the time of writing, international spot prices are fluctuating around $4,000 per ounce, depending on market conditions and geopolitical events. Kitco +1. For perspective, only a few years ago, many people believed $4,000 per ounce was impossible. Now it is reality, and suddenly, the flakes sitting in a vial begin looking very different. The remarkable part is not simply the number, it is what created it. Central banks continue purchasing enormous amounts of gold reserves. Investors continue treating gold as financial insurance. Periods of inflation continue pushing attention back toward physical assets that cannot be printed or created overnight. World Gold Council +2 gold remains unique. A company can issue more shares. A government can print more currency. A mine cannot print another mountain. Nature controls the supply. Humanity only discovers it. That reality changes how many prospectors think about their finds. Some sell immediately. Some hold for years. Some build collections slowly, believing future prices may justify patience. Major financial institutions remain divided on exactly where gold will go next, but many continue forecasting elevated prices into late 2026 and beyond. JP Morgan Chase +2. Then comes another important question. Should a prospector sell flakes, pickers, nuggets, specimens? The answer depends on the market standing in front of you. Fine placer gold usually follows metal prices closely. Large nuggets often attract collector premiums. Visible gold in quartz enters an entirely different market, where rarity may matter more than weight. Sometimes the specimen becomes more valuable than the gold inside it, and that surprises many new prospectors. Because gold marketing is not simply selling metal. It is matching the gold to the right buyer. And perhaps that is where prospecting changes forever. The moment you stop asking, "How much gold did I find?" and start asking, "What exactly did I find?" Because ounces tell one story, the market often tells another, and somewhere between those two numbers, the real value begins to appear. The surprising truth is that recovering gold and valuing gold are completely different skills. Finding it requires geology. Recovering it requires patience. Selling it requires understanding people, because the market rewards some pieces far beyond their weight, while others quietly become worth less than their owners expected. And before any prospector decides to sell, there is one final question that changes everything. Who should you sell it to? And that is where our final chapter begins. Eventually, every prospector reaches the same crossroads, not at the river, not at the pan, not at the scale, but here, the moment they ask, "Do I sell it or do I keep it?" Because for the first time in the journey, the gold stops being geology and starts becoming finance. The market does not care how cold the river was. It does not care how many buckets you dug. It does not care how many miles you walked. The market sees only three things: weight, purity, rarity. And each one speaks a different language. Weight speaks to refiners. Purity speaks to investors. Rarity speaks to collectors. A vial full of fine placer gold may follow the international gold price very closely. A large nugget may command a premium simply because large nuggets become rarer every year. A beautiful specimen with visible gold inside quartz may enter an entirely different world where collectors compete not for ounces, but for uniqueness. And suddenly, gold stops behaving like a commodity and starts behaving like art. Now comes the remarkable part. The world of 2026 has reminded investors why gold has survived every financial experiment humans have ever created. Gold reached historic highs earlier this year, breaking price levels many analysts once considered impossible before entering a period of sharp volatility and correction. Even after those fluctuations, gold remains one of the strongest performing major assets of recent years. Central banks continue buying enormous quantities of gold for their reserves, and many expect those purchases to continue throughout the coming years. World Gold Council too. Why? Because governments understand something prospectors learned long ago. Gold cannot be printed. Gold cannot be manufactured overnight. Gold cannot be created with a keyboard. The earth decides the supply. Humanity only discovers it. That reality has carried gold through wars, inflation, currencies, recessions, and generations of uncertainty. And perhaps that explains something every prospector eventually feels. The strange reluctance to sell, because after following gold through rivers, through black sands, through concentrates, through pans, through scales, the gold no longer feels like a product. It feels like a story, a memory, proof that the landscape spoke and someone listened. Perhaps that is why many prospectors keep their first nugget forever, not because it is worth thousands of dollars. Sometimes it isn't, but because it represents something much harder to buy: patience, persistence, curiosity, the willingness to believe that an ordinary piece of ground might still hide something extraordinary. And that may be the greatest lesson gold ever teaches. Because prospecting was never truly about becoming rich. It was about learning to see what others overlook, to recognize value before it becomes obvious, to trust evidence over assumptions, to follow clues rather than crowds. And somewhere tonight, a mountain continues weathering, a creek continues sorting gravel, a bedrock crack continues protecting a tiny piece of gold from the current above it. waiting for another storm, another season, another generation, waiting for someone willing to ask the same question prospectors have asked for centuries. What if there is still something hidden here? Because gold is not disappearing, the earth is still preparing it, the rivers are still moving it, the landscape is still hiding it, and the next discovery may already be waiting beneath someone else's footsteps, or perhaps beneath your own, from hidden ground to paid dirt, to concentrates, to gold, to markets. The journey is complete, but somewhere beneath the mountains, the earth has already begun writing the next story. For millions of years, quartz has quietly protected one of Earth's greatest treasures. It carried gold upward from unimaginable depths. It sealed it inside ancient fractures. It released it through weathering, and eventually it scattered nuggets across mountains, valleys, deserts, and rivers where patient prospectors continue searching today. But here's something few people realize. Quartz wasn't carrying only gold. During those same geological events, while mountains cracked, while magma slowly cooled, while mineral-rich fluids surged upward through the Earth's crust, nature was creating something else. Something that doesn't glitter like gold. Something that many hikers unknowingly kick aside every year, yet in exceptional quality. A crystal no larger than the tip of your finger can quietly be worth more than a heavy gold nugget resting beside it. At first, that sounds impossible. Gold has fascinated civilizations for thousands of years. Empires have risen because of it. Wars have been fought over it. Fortunes have disappeared chasing it. So how could one ordinary-looking blue crystal ever compete? The answer begins where almost every valuable gemstone begins. Not inside jewelry stores, not inside museums, but deep beneath ordinary mountains, where pressure, heat, and time patiently work together, long before anyone ever discovers the result. Imagine hiking through an old mountain range somewhere in the western United States. The trail seems ordinary. Granite outcrops rise beside you. Loose boulders cover the hillside. Pine trees hide the distant ridges. Nothing about the landscape suggests extraordinary wealth. Most hikers continue walking. Experienced rockhounds begin slowing down, not because they see gemstones, because they recognize the rocks capable of hiding them, and perhaps the most important of those rocks appears surprisingly plain. From a distance, it looks like nothing more than pale granite. Walk closer. Something feels different. The crystals seem unusually large. Individual feldspar crystals are easily visible. Quartz appears in thick, glassy masses. Everything looks oversized, almost exaggerated. That rock has a name. Pegmatite. To most people, it is simply another outcrop. To experienced collectors, it is one of the most exciting rocks on Earth, because pegmatite doesn't simply contain minerals. It grows giants. But why? The answer takes us back beneath the mountain. Imagine a giant body of molten granite slowly cooling several miles underground. Most of the magma solidifies first. Quartz begins forming. Feldspar follows. Dark minerals crystallize. Eventually, only a tiny amount of liquid remains. Yet that remaining liquid is unlike ordinary magma. It contains enormous amounts of water. Rare elements, volatile gases, beryllium, lithium, fluorine, cesium, elements that refuse to enter the earlier crystals. Instead, they became concentrated inside the very last drops of molten rock. Now something remarkable happens. Those final fluids force their way into nearby fractures. Unlike ordinary magma, they cool incredibly slowly. The crystals suddenly have something they almost never receive. Space, time, freedom to grow. Instead of tiny crystals packed tightly together, gigantic crystals begin developing. Some eventually become larger than a human arm. Others grow into perfectly formed transparent columns, and hidden among them, nature quietly begins creating some of the world's most valuable blue gemstones. Now here's the first field technique. Most beginners search directly on top of pegmatite outcrops. Professionals often inspect the slope below. First, why? Because weathering has been attacking that pegmatite for millions of years. Rain enters tiny fractures, winter ice expands them. Summer heat weakens them again. Little by little, individual crystals escape. Gravity does the rest. Instead of remaining inside the outcrop, loose crystals slowly migrate downhill, sometimes only a few feet, sometimes hundreds of yards. Long before you discover the original pegmatite body, nature may already have placed samples directly in your path. That simple observation has led experienced collectors back to remarkable crystal pockets. Another discovery begins appearing almost immediately. Not every pegmatite deserves your attention. Some contain nothing more than quartz and feldspar. Others quietly concentrate rare minerals that occur almost nowhere else. How can you tell the difference? Look at the crystal size. The coarser, the pegmatite. The longer the final fluids remained active. Long-lived pegmatites had more opportunity to concentrate rare elements, and those rare elements became the building blocks for extraordinary gemstones. Now another reward. Watch how the pegmatite behaves. Does it continue as one thick body through the mountain, or does it suddenly split into several thinner branches? Experienced geologists rarely ignore branching pegmatites. Those branches often represent multiple injections of mineral-rich melt entering the surrounding rock. Every new pulse changes the chemistry. Every change creates another opportunity for unusual crystals to develop. Nature isn't simply building rock, it's conducting one of the slowest chemical experiments on Earth. And eventually, one remarkable blue crystal begins appearing. Not sapphire, not topaz, not turquoise. A gemstone that shares the same mineral family as emerald itself. Aquamarine. Most people know it only because of its beautiful ocean blue color. Few realize they're looking at the blue variety of beryl, one of the most important gemstone minerals ever discovered. Its color isn't paint. It isn't a surface coating. It was built into the crystal while it was growing, as tiny amounts of iron became part of its atomic structure millions of years before the first humans ever walked the Earth. Now imagine discovering one lying loose among weathered pegmatite fragments. Should you keep searching downhill, or should you change direction? Experienced collectors almost always turn around, because one loose aquamarine crystal usually tells a much bigger story, somewhere uphill. The pegmatite that released it may still remain hidden beneath the surface. And if one crystal escaped, others may still be waiting inside. The remarkable part. Nature almost always leaves more than one clue. It rarely rewards the first observation. It rewards the person who follows the evidence, and that evidence is only beginning to unfold. But here's where the story becomes even more interesting. Finding a single aquamarine crystal doesn't necessarily mean you've found the treasure. Sometimes, it means you've only found the messenger. Imagine kneeling beside a weathered mountainside after spotting a pale blue crystal among loose gravel. Most beginners become excited and begin searching the ground around their feet. Experienced collectors do something completely different. They begin looking uphill, not because they expect another crystal lying on the surface. Because gravity always tells the truth. A loose crystal didn't grow where you found it. It traveled. Perhaps only a few feet, perhaps 100 yards. But somewhere above you, the mountain quietly remembers where it came from. That is why professional collectors rarely search randomly once they discover their first crystal. They reverse the journey. They follow the mountain backward. Every larger pegmatite fragment, every fresh block of quartz, every oversized feldspar crystal, every broken exposure, becomes another clue leading toward the original crystal pocket. And sometimes, that journey ends where nature has been hiding treasures for millions of years. Now another discovery begins. Notice the pegmatite itself. Some sections appear solid and lifeless. Others suddenly contain open spaces, small cavities lined with perfectly formed crystals. These cavities are known as myorelitic pockets. They formed during the final moments of pegmatite crystallization. As the last volatile, rich fluids became trapped inside shrinking spaces, pressure slowly decreased. Instead of filling completely with solid minerals, tiny chambers remained open. Inside those chambers, Crystals grew freely into empty space. Unlike ordinary minerals crowded together inside solid rock, these crystals developed complete faces, sharp edges, and remarkable transparency. Some of the world's finest aquamarines have emerged from cavities no larger than a backpack. Now comes another professional technique. Don't immediately strike every pegmatite with a hammer. Walk around it first. Fresh collapses, small natural openings, weathered fractures, sometimes reveal cavities without damaging the outcrop. Nature often exposes the first clue long before human tools become necessary. Patience frequently protects discoveries that haste destroys. But perhaps aquamarine isn't the only surprise these pegmatites keep. Imagine discovering smoky quartz beside aquamarine, then feldspar, then black tourmaline. At first, they seem unrelated. In reality, they are geological companions. Certain minerals enjoy forming together because they were born from the same chemical environment. When experienced collectors discover tourmaline crossing pegmatite beside smoky quartz, they don't simply admire the minerals. They become curious, because the chemistry that produced one rare crystal often produced others nearby. One discovery quietly predicts the next. Now another mystery. Why do some aquamarines remain pale while others display an intense ocean blue color? The answer isn't size, it isn't age, and it certainly isn't polishing. It begins at the atomic scale. Tiny amounts of iron entered the crystal while it was growing. Not enough to weaken it, just enough to change the way it absorbs light. The deeper and more balanced those trace elements became during crystal growth, the richer the blue color eventually appeared. That tiny chemical difference can transform an ordinary crystal into one sought by collectors around the world. Now, another practical technique. When examining aquamarine in natural daylight, rotate it slowly. High-quality crystals often maintain their color from several viewing angles. Poor quality material may appear washed out the moment the light changes. The mountain quietly performed this quality test long before the gemstone ever reached a jeweler. Now another discovery. Pegmatites eventually disappear. Rain continues falling. Frost continues expanding. Entire outcrops slowly collapse. Crystal pockets break apart. Loose gemstones begin entering small mountain streams. At first they move easily. Then something remarkable happens. Unlike ordinary rock fragments, gemstones are surprisingly durable. Many survive transport with their crystal form still recognizable. Streams sort them exactly as they sort gold. Heavier material settles where water slows. Natural cracks capture them. Coarse gravel protects them. And suddenly, the story begins sounding familiar, because although gemstones and gold formed differently, nature often concentrates them using exactly the same forces. Gravity becomes the collector, water becomes the sorter, time becomes the patient craftsman. Now another reward. If you discover abundant pegmatite float entering a mountain drainage, don't ignore the first inside bend below it. Inspect gravel resting behind stable boulders. Search exposed bedrock pockets. While not every stream carries gemstones, those that drain productive pegmatites occasionally preserve remarkable surprises long after the original crystal pocket has vanished. And perhaps that's the greatest lesson these blue treasures teach us. The mountain never reveals everything at once. It leaves clues. One crystal, one fragment, one cavity, one weathered outcrop, one quiet stream. Each discovery asks the same question. Will you stop here, or will you keep following the evidence? Because every remarkable gemstone discovery in history began exactly the same way. Someone noticed one clue that everyone else ignored. Then they asked one more question, walked one more ridge, climbed one more slope, followed one more fragment, and eventually the mountain answered. Perhaps that is why nature's greatest treasures rarely belong to the strongest explorer or the one carrying the most expensive equipment. They belong to the person willing to slow down long enough to let the landscape speak. Because every pegmatite, as every crystal pocket, every loose aquamarine, every weathered mountainside, is quietly preserving another page of a story that began hundreds of millions of years ago. A story written not in ink, but in crystal. And the remarkable part is this. Somewhere, on an ordinary mountain that thousands of people may hike this very year, another untouched crystal pocket may still be waiting in complete silence. Not because it is impossible to find, but because almost everyone is looking for the wrong clue, and perhaps the next extraordinary blue crystal has already begun its journey toward the surface, waiting for the one person who has finally learned how to read the mountain before the mountain reveals its greatest secret.